All right, today we're going to take a look at a really important rule called the chain rule. So we've learned how to do derivatives of products, quotients, all kinds of functions. Now we're going to take a look at composed functions. So remember, if I take a function and plug it into another one, this is an operation we call function composition. So let's pretend that f of x is made up of h of x plugged into g of x, so g of h of x. The question is, how do I find the derivative of f of x? Well, this is right here is called our chain rule. The way that we do it is we work our way outside in. We take the derivative of g, so g prime of h of x times h prime of x times the inside. So this is kind of a confusing looking rule. I think it's kind of more understood through some examples and some practice. So let's take a look at this function here, 3x minus 1 to the 4. As it stands, we have two options. We could expand that binomial, so multiply 3x minus 1 times itself 4 times. Yikes. And then get a huge polynomial and then do the power rule. That's one option. Another option, we could do the product rule, 3x minus 1 times 3x minus 1 times et cetera, et cetera. And we all want to avoid that if we can. So the chain rule actually is going to streamline that whole process. It'll do this a whole lot quicker. So I'm going to show you sort of a long route, and then we'll see a shortcut. So first, let's identify h and g. It looks like 3x minus 1 is being plugged into the function x to the 4, because you could view f of x as h of x raised to the 4th power. In other words, g of h of x. So if I identify my h and my g, I can find my h prime and my g prime just using my power rule. And then I can plug right into the formula for the chain rule, g prime of h of x times h prime of x. And that gets me 4 times h of x cubed. I took x out of g prime and I put h in its place, times the derivative of h, which is 3. So I could plug that h of x in, which is 3x minus 1, and then that 4 and 3 make it 12. Okay, so that seems a little lengthy. Identify h, identify g, etc., etc. Let's take a look at the original problem, and let's just pretend we did the power rule. So we move the 4 out front, and then we change that exponent to a 3. And then if we tack on the derivative of the inside, which is just a 3. All right, that gets you to the same result. So that's kind of how you want to start viewing the chain rule. You can, if you want to just follow line for line, every single identify function, identify derivative, etc., you can do that. That's totally fine. But I think it's beneficial to start seeing a few moves ahead, kind of like playing a game of chess. This is something raised to the 4th. So I take the derivative of that, 4 times that thing to the 3rd, and then multiply by the derivative of the inside, and then simplify. So I want you to try this one right here. I'm just changing the inside function. It's still raised to the 4th. That 3x minus 1 is now x cubed plus 2x. Go ahead and pause. Take a second. Try it for yourself. And in 3, 2, 1, here is the derivative. Should be 4 times x cubed plus 2x to the 3rd times 3x squared plus 2, because that 3x squared plus 2 is the derivative of the inside. Let's try another one. A cube root. Okay, so this is actually a chain rule problem. Give you a little hint here. Algebra first, calculus second. So write it like this. Take a second and try the derivative, and then in, okay, 3, 2, 1, you get the idea. Here is the derivative using that chain rule. Just keep in mind, so that 10x plus 7, that comes from the derivative of 5x squared plus 7x. Keep in mind that we don't want to have complex fractions, nor do we want to have negative exponents, so you'd probably want to clean it up to look like this. That should give you plenty of information to answer those questions on Schoology.